11 and 12. I'm going to do these backwards. I'm going to do 12 first because it leads into 11. If I did 11, we'd be doing 12 also. So the main thing is this is just a new way to do reduced row echelon form. There's a portion in the textbook if you want to read about it. So basically they do the same thing. Sometimes one's a little more useful than the other, easier or something, but they will both give us the same answer. So in this case, instead of using an augmented matrix, we use three matrices. And so there's a matrix C times the variable matrix, and we'll see what those look like specifically when we get into 11, is going to be equal to some answer matrix D, which is basically, in this case, would be a 2 by 1, a 3 and 7. So we'll see how that looks. To solve this, what we do is we multiply, because it's an equation, we can do the same thing as long as we do to both sides. I'm going to change colors here just to make it clear. So we would multiply both sides by the inverse of C, and the reason we do that is because the inverse of C times C is the identity matrix, which is in matrix language is 1. So these sort of will cancel each other out, and we'll just be left with X equals C times the inverse of C times D. Notice I have to multiply from the left-hand side. I can't put it the other way around. So I'm certainly not taking the inverse of D, so this is a multiple choice one. This is the correct one. This one's not correct because C is on the wrong side. It would give us something different. And of course this one's not, we're not taking the inverse of D, we're taking, because we're wanting to get rid of matrix C, so we have to take that inverse. So that's why, that's what 12 is about, just understanding how it is, and I want you to understand how this formula works, that Cx equals D, it ends up being X, we're solving for X, we have the inverse times D. So that's how that works. Now, this is wanting us to use the matrix conversion method. So what I'd like to see is have the thing set up right. So we're going to have the coefficient matrix, 3 and 6, that's the first matrix, and 2 and -1. That gets multiplied by the variable matrix, X and Y. And if you did this multiplication, you'd see that. Basically, when we're doing the reduced row echelon form, we're able to just sort of ignore this and just remember that the first numbers go with the X's, the second numbers go with the Y. And then instead of doing an augmented matrix, we have a third matrix, which are the constants over here, 3 and 7. And so the method to solve it using this is we're going to enter this as a matrix and this as a matrix. We could call it C and D, and then we're going to take the, let's go ahead and label it. Yeah, we'll label this one as C, this one as D, this one is just X. We don't actually enter it because it's variables. And once we have those in there, to solve this, we're going to take matrix C, take its inverse, and then multiply it times matrix D. And if we use this as, put this in with an augmented matrix, this is the other method, would be 3, 6, 3, 2, -1, 7. We would just enter one matrix, and then we would do reduced row echelon form, and we'll come up with the same answers. Maybe we'll do both, maybe we'll just do one, but because this is really the end of the line for matrices. Yeah, so then we come here, and also I wanted to show you, I've been, since we've been working on this, we've got a few matrices that are kind of piling up. Let's see, it's clear. I'm going to go to my memory, number 2, memory management, and we can delete some of those matrices that we're not using anymore just by coming here and we hit delete, 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 delete. Okay, so if you want to get rid of them, you don't have to. But now that that's done, I can go back to my matrix. I'm going to set up matrix C. Sometimes when you clear them out, then you could use the same letters. Then you're not going to get as confused. 2 by 2. And we're going to enter this 3, 6. Oops, not there. Clear that. That's 2. Enter there. Oops. 3, 6, 2, -1. And again, just be careful on your entry, double check everything, because garbage in, garbage out. Quit, I come back here, go back to matrix. This is, there might be an easier way to do all of this, but this is how I figured out to navigate all of this. This is going to be a 2 by 1, 2 by 1, and it's just 3 and 7. Okay, so that's our D matrix. And so now we're at the main screen. We come here, we're going to take C, so we're using its name. We take its inverse, right, because this is what we're doing right here, the solution. And then I think you need this. If not, I've gotten so used to having it, it don't hurt, but it might not work if you don't have that multiplication times D, if you just write them next to each other. And then it gives us this answer, 3, -1. So we have solved the system, and looking at this, 3 is the x, y is -1 is the 1. So solve the system. We could list this as 3, -1 as our solution, box it in, you know, and I think, let's see, I think I put the answer in here. Did I? Maybe I didn't copy the answer, but that's the right answer anyway. While we're here, let's just go ahead and take a look. Just show you matrix. Let's just put it in the augmented matrix. So we're going to do this part. Oops. Just want you to see that this is the same, will give us the same answers. This is, though, is going to be a 2 by 3. So we're putting everything into one matrix. I like it a little easier. It seems to be easier. It's but you know, second quit, and now we want to do reduce row echelon form. Remember, if you arrow up, it's a little bit faster, and then we're doing that on matrix A because that's where we've got it stored, and we see the same thing. It's the answers may be a little more cumbersome because we've got this reduced row echelon form, the ones here, but x is 3, y is -1. So we see the same end result. We just have to read it differently. So that's what we did on matrices. And I'm going to take a little break, and then we'll move into more to the counting and what else, probability. All right, thank you.